Last problem on the world's longest learning guide. A golfer stands at a tee that rests 30 feet above the green. So here's some. Oh, wait a minute. Whatever. Okay. So here's some dude up here. He's going to be golfing. Woo, that's my imitation of a golf club. That's what they look like. There's a head. There's the tee with the ball. And we are up here 30 feet above where the green is. Let's put the green over there somewhere. And what does it say? Well, it says the green is 434 feet away. So we know that's 434 feet. And we know we're 30 feet up. If the golfer hits the ball with an initial speed of 115 feet per second, estimate the angle with which she would need to hit the ball in order to get a hole in one. So I guess I goofed this up, but let's assume that that hole is 434 feet away. So what do we know? Well, what do we not know? We don't know the angle. Based off of this terribly out-of-scale drawing, it's probably going to need to be like that. We don't know this angle theta. We know that the velocity is 115, so we can find the vertical 115 sine of theta, and the horizontal 115 cosine of theta. And we can use oh my gosh, we can use that to figure out what does that angle need to be in order for this ball to plop directly into that hole, which, yeah, pretty unlikely. Don't have any idea if 434 feet away is a reasonable distance to hit a golf ball, because, again, I'm super unathletic. But we're just going to follow the math and see what happens. So let's go ahead and write this parametric equation. Again, just like the last two problems, x is going to equal the speed, which is the horizontal component of velocity, 115 times the cosine of theta times time. And y is going to equal the vertical component. I'm a liar. It's going to equal the vertical motion model, which we've used all year long, which is, since we're talking about feet, still going to be negative 16 t squared, plus our vertical initial velocity, which is 115 times the sine of theta, times our time, plus, scoot over a little bit so you can see, plus our initial height, which is 30. So we have our two equations here. What angle should we try to see if we can get there? I don't know. Let's try theta equals 30 degrees and see what happens. So type that equation in, type 30 degrees. What should you do for your window? Well, think about it. What are the important pieces we need to see? We need to see the y min at 0. We need to see the y max. Well, we don't really need to see the max, but we know it's starting at 30s, and we know it's going to go up from there. So let's just try like 100 and see what happens. We'll at least be able to see it, most likely. X min, we should do our starting point, which is 0. X max, let's do our max point, which is 434. T step, we need to make sure the ball gets there. So let's just choose a T min of 0, starting when we hit it, and a T max, again, I don't know, let's try 10 seconds and see how it goes. Let's enter this and see what we get. And you know what, I just totally made up all this random stuff, but you couldn't have asked for a better first guess. But what happens when you graph this? You get this little fella right here that goes like that. And remember, our biggest x value right here is the hole. So we're not quite there. We want to move that cursor over to that hole. So what should we try? Well, let's try increasing that angle a little bit. Maybe that'll get us there, or maybe that will take us in the other direction. Let's see though. Let's try 35 degrees and see what happens. When we type 35 degrees in, we can redraw this graph, and look what happens. It goes a little bit farther, so it takes me a little bit higher. Wow, that's frumpy. And it goes a little bit farther. How far does it go? Well, let's trace to it, and let's see what happens. So I'm tracing, and I'm moving my cursor to the right. It's going to hit its max around 2.5 or so, and now it's coming down. Where are we? T is about 4.5 now. Between 4.5 and 4.6, it's hitting the ground. At 4.5, the x value is 423, and we're looking for the x value of 434. So it doesn't look like we're quite there. Let's get it a little closer to the ground just to be sure. 4.55 gets us pretty close. We're at 428, and we're negative, so we're still not far enough. So let's go back and let's increase that angle to, say, 40 degrees and see if that does it. That'll most likely be a little bit too far, judging on how this has played out so far. If I graph that, whoa, can't see the top anymore. Whoa, I can't see the bottom. That's telling me I've gone too far. But let's trace over to confirm our results. And let's see, at 5, we're at 440 and just below the y-axis, the x-axis. So we're pretty close. Let's try 4.95. X value is 436 and the y value is almost 4. So here we've gone too far because x is too big and y is telling us we're still in the air. So I'm going to try something close but different. Let's try 39 degrees. That'll probably get us pretty gosh darn close enough maybe to call it good enough for this problem, because we're not going to get it perfect. But let's see what happens. This looks to be a tiny bit too far, so what I'm going to do is I'm actually going to change it to 39, insert 0.5. Always remember to change it in both slots there. So we're just doing a little guess and check here. Nothing super technical, just kind of playing with the function, seeing what we can get this model to look like for us. So again, it looks like we're a little too far. Let's go over to 4.5. Let's go over. Now notice it's in the air longer because it's going farther. And at 4.9, we're still 4 feet above the ground, and we're 434.8 feet already, so we've gone too far. So, goodness gracious, let's try 39 point, 1. See what happens. I don't know. Maybe I've been talking too much and I haven't been paying close enough attention. Did 39 already go too far? Maybe I'm crazy. Looks like it did. I'm a nut job. My bad. The point is, play with this stuff. You can find something that's pretty close. So I'm going to try 38.95, and then I'm probably going to stop and say, if you want to keep playing with this, you are more than welcome to. But I've probably had about enough. Whoa, I just goofed something up. What did I do? Alright, so here's the deal. I just spent like 5 minutes plugging in different theta values, and I think this is annoying, and I'm tired of doing this. But what I ended up finally doing was a theta value of 37.2, I believe. I'll verify that in a moment. But I figured out that at the time of 4.74, when t equals 4.74, with this theta value, I get an x of 434.188, and I get a y of 0.085, and my theta value was 37.2, and I'm going to call that gosh darn good enough, because we get the idea. We don't need to keep playing around with this. You can find a good angle that'll get you pretty close, which is kind of cool. And maybe if I went 37.1, maybe I'd be even closer, since this is a little bit too far still. But the thing is, I just want you to understand how you could play with these pieces and figure out something that you might actually want to know, which is pretty cool. So there you have it. That is the end of the learning guide. Maybe you can hear I'm still clicking numbers. But 4.735. All right, I'm going to say 37.1 degrees is like a very good angle to get you a hole in one there. And let's totally stop doing math.